everybody. Tonight, I'm really pleased to welcome Justin McCollum, who's actually my predecessor as novice chair and taught these for many years. And he's going to talk about something that I am a novice at, Stellarium. And for me, it's even I've got a cat coming. It's even all the various computer atlases. I'm still in the Stone Ages using paper atlases, but there's quite a bit more customization you can use with a computer atlas. Stellarium is one of the most popular. And so I'd just like to welcome Justin. This is going to be one of a series of 3 novice talks he's going to give to us every few months over the next few months in the fall and also hopefully in the winter. So Justin, thank you very much and take it away.
Okay, let me see if I get my share screen here.
And while Justin's bringing up his screen, I wanted to just remind everybody, if you have any questions, feel free to use the chat function within Zoom. Ask your questions there. I'll keep a running list of all of the questions that we have, and we'll get to those at the end of Justin's presentation.
Okay,
so,
everyone see it?
We do, Justin.
All right, so let's start with the program here. So we'll go through 5 particular sections. There's the origin of the software and installation. You have the general tools and features. You have program extensions, advanced features, and simulating astronomical events. Now, the origin of the software. I don't know how many people are familiar with Stellarium, but it is internationally recognized as a freeware and shareware program, not for just amateur astronomers, but for any space enthusiast and educator around the world. You get in different languages. It's available for the 3 types of operating systems, PC, Macs, and Linux-based computers. It's a GNU general public license software, so it's free to use. There's apps for your smartphone. There's Stellarium Web for those who have Chromebooks. The Stellarium Web is a very general version of Stellarium, and it only works when you have access to Wi-Fi or the 4G or now the 5G networks. It's written in a program called Qt, which is a widget toolkit using C++, creating a graphics user interface and allowing for cross-platform applications. That's why you can run it on PC, Macs, and with Linux-based computers. Of course, you have to download the right version. Now, Stellarium Mobile is what we refer to as a fork of Stellarium. So it's an independent software version of the original program that you can run on your apps. So it's cross-platforming usage for all mobile devices, particularly for smartphones and e-tablets. I don't know if anyone's familiar with the Les Trophées du Libre. It's an international competition for awards with visual graphics softwares and studio effects, but it won the gold. It was the gold award winner for its version 0.7.1 in the education category for free software competition back in 2006. This is the current version, and we're going towards a version 1.0.0. So right now the latest is 0.21.0. And it's very good, particularly for developing astronomy labs for schools and higher education. Now, for installing it, of course, you go to stellarium.org. It's not a secure HTTP, but I've been going to this website for many years. If you don't want to install, usually I wait for like version 20 to become like version 20.4, so it's a bit stable. When they're updating features all the time on the program, they're always installing and updating features. The latest one I have is Stellarium 21.0, and here you got a mailing list, discussion board, and you can contribute to the program as a developer, as well as report bugs and request new features. This is the Stellarium user guide, and you can download it. It's a very extensive manual. Well, for extending the Stellarium, doing practical astronomy for any citizen science project. And Fabien Charot is an astronomer and a software developer who began this project in France in the summer of 2000. So these are the appendices, so you can deal with the Bortle scale of light pollution, deal with the plugins. If you want to look at quasars and pulsars, star catalogs for cross-referencing, precession and rotation, planetary positions, proper motion of stars, the documentation license, and the acknowledgements, because there's hundreds of people that have contributed to the development of this program over over the plus 20 years. And you can get up to 1 million deep sky objects with extended catalogs. You can get up to more than 150 million stars. So you have your default catalog, but you can go from 600,000 to 177 million stars, from 80,000 deep sky objects to over 1 million deep sky objects. You can do realistic atmosphere, view of the realistic atmospheres at clear sky, sunrise, sunset, images of nebulas, not just the Messiers, and different cultures for constellations, as well as simulating iridium flares, supernova simulations, 3D sceneries, and a fisheye projection, just like planetarium domes. So this is what you would see with the program. So basically, it looks like a planetarium dome. If you had the sky overhead, you would have north up to the top, south at the bottom. You have the east and the west. So this generally, when you open the program, it views it towards the south. So here's the sun. If you see this haze around the horizon, just press the F key. It gets rid of the fog effect. Now you have two horizontal navs. There's the vertical and there's the horizontal. Now, if you don't have any of your plugins loaded up, it's going to be a very narrow one, but you'll have things like making the screen larger, making it smaller. You'll have the telescope. You'll have your right here. This is going to be your deep sky objects, your planets, the atmosphere, the horizon, the grid system, and your constellations. And going forward, backward in time, you can set up your location, the time of day, your sky features, your fine objects. You can configure the sky to add in some of these plugins. And of course, there's the astronomical database. Well, this is the astronomical calculations windows if you want to project paths of the comets across the sky, as well as simulate other events. And then there's, of course, there's the help tool right there. So the vertical nav, and if you don't want to use the your mouse, you can just press your F keys. I don't know what's going to be for Apple computers, but for Windows, these are the F keys you would use for searching for objects in the night sky, for your sky and viewing options, your location, date, and time, doing astronomical calculations, configuring the program or the software. Now, from left to right, this is the extent I have with the icons. So you have here, you have your constellations, you have your asterisms, you have your galactic coordinate systems, supergalactic. The ICRS is for the J2000 epoch. For your equatorials, you got the equatorial for the dates. You can take into account precession. There's the horizontal for the alt-as, the crown, the atmosphere, and the cardinal points. For mapping, you get your deep sky objects. You can get your DSS for the deep sky survey. For full screen, you can flip the sky horizontal or vertical, and this is going from left to right as you go down and across. And for changing the time sequence, the angle measure, the equation of time. So just a lot of, and of course, going from Alt A to Control A is the difference from showing the asterisms in the night sky versus measuring the angle between two objects in the night sky. Now, exploring Stellarium. The basic approach, the comma, the period, and the semicolon keys. Well, that will give you this one here. The comma will give you the ecliptic of date, which is the plane of the solar system. This is the equator with the period key. You can see right here where you have your spring, your vernal equinox. And then, of course, here's the meridian, which is the semicolon key. You press the F key to get rid of the haze. From the horizon, it's the fog feature. And if you want these features to appear and disappear, it's just pressing the same keys. So Building up to a stargazing night. Of course, if you want the screen, if you want to look at a small area of the sky, you do the page up key. If you want to make the sky look larger, it's going to be the page down keys. You can access the location window. And if you don't have your location anywhere here, you can type it in, go to Google Maps, put in the latitude, longitude, and elevation. And of course, put in the time zone. You can click off the custom time zone. It'll give you the time zone of your location. Or you can get your location from the network, or get your location from GPS. And you can go anywhere in the solar system. You can see what the sky looks like from Saturn. And you actually get the rings across the sky and see what the sky looks like from Saturn or any place in the solar system. The timing is important because you can deal with the date and time, the Julian day. Remember, this is international, so you're going from year to seconds. You get the Julian date or the mean Julian date. The field of view is in the field of view is in degrees. This is the frames per second passing by. And this is your location. I did this for the George Observatory. And of course, 20 meters for the altitude. Now I get the sky. And let's say I want to see what the sky looks like during the daytime. I press the A key, I can eliminate the atmosphere. I press the F key, I can eliminate the haze. I press the P key, I can eliminate all the bodies in the solar system. And this is what I get. So it's like a star atlas. Now it doesn't have the relief like a regular atlas where it has the stars big and small by magnitude and lays out all the key features for the deep sky objects. So it doesn't have that, but it will project those onto the night sky. You can change the label of markers so the names of the stars do not appear. And you can get, just like with a star atlas, you get the Milky Way, you get the deep sky objects, you get a sky of stars, and you can simulate this going backwards in time, forward in time, or backwards in time. And by pressing the atmosphere key, you can change the number of stars that are visible in the night sky versus stars that would not be visible with an atmosphere. So the date and time window is the F5. The K key is to stop at a particular moment in time. If you want to set the date and time, I always press the K key first. That way you can get the time to the exact second. Your windows as they appear up against the view screen are going to be semi-transparent. Just be aware of that. So if you're worried about the stars in the background, you can just press keys to make the sky look black. You can have multiple windows up, so you can have your location screen, your finding your object screen, so you can see where you are on the surface of the Earth. You can find your object in the night sky, and you can add or remove windows on the view screen. And you can click on any on the icons on the horizontal nav to add or remove features from the night sky itself. So this is the sky and viewing options window. These are your tabs, so you can, for instance, adjust the light pollution. You can remove names for stars. You can make the stars look spiky. You can limit the magnitude. You can change the scale of the zodiacal light, although it doesn't give you the Guggenheim. And you can make the Milky Way look bright and saturated. So if it's from, let's say, the brightness goes from 1 to 0, it affects how much the saturation here. If I put the saturation, I would probably show you this when I get time to do the Stellarium program, but for the brightness itself, it affects the coloring. With the saturation, it either makes the Milky Way look invisible or brightens it up. But if it brightens it up and you reduce the coloring down to 0, it'll make the Milky Way look black and white. So you can make the Milky Way look black and white. You can also increase the brightness to maximum, which goes from 1 to 10. That's for the brightness, and the saturation goes from 1 to 0. It makes the net Milky Way go from being colored to being black and white. And we'll just go through all the tabs here. This, of course, is going to be for the finding tab itself, for finding objects in the night sky. So you type in your object. You get the Simbad, you get the position, you can list the objects, you can go to the Simbad website and find a deep sky object that's not in Stellarium. and project against the night sky, or put in the position tab. Even if you want to find some globular cluster orbiting some galaxy, and all you know is the galactic coordinates, you can type it in and you'll find it right there on Stellarium. Oh, and going back here, this is for adjusting for solar system objects, the markings, landscapes, the star lore for constellations in different cultures. Now, let me go forward a bit here. This is a lot different from earlier versions of Stellarium. Now, for the horizontal nav, you have your keys for looking, for instance, at the ground, the atmosphere, the cardinal points, and of course, for looking for deep sky objects. So right around here, you can either click on the nebulous feature, which is the galaxy icon, or press the D key to get the deep sky objects appearing in the sky, and press the I to get the background images. This here is for the time setting. The A key gives you back to your current time. So J goes back in time, K is stopping time, A takes you back to your current time, L is going forward in time, so you can go back thousands of years or go forward thousands of years and see how the constellations change over time. So there's the galaxy feature, and those are your objects right there. So you do get the crosshairs, you do get the dotted circles, the squares, like you would for any atlas for those deep sky objects. Now, if you work on all the names here, you can remove those labels. All you get are just those deep sky objects appearing as just the markers. And of course, you can limit the number of labels, you can limit the number of objects, you can do it by magnitude. So if you focus us on these objects, you can get more of them to pop up with the names. So you can put magnitude limits on those markers. So you're not, and with the labels, so you're not overly saturating the sky with a lot of deep sky objects. Here I got a lot of deep sky objects, but I can limit the markers based on magnitude. So if I focus on a large area of the sky, of course, with Stellarium, you're getting a lot of objects. So you have to sort of judge how much in the way you want for labeling for the objects you want to observe. Now, for constellation patterns and boundaries, these are the keys right here. So I can make constellations appear, boundaries. You don't have to have all this at once. You can have the constellation lines appear with the names or just the names. You have the artwork. You have the boundaries accepted by the IAU. And of course, you get the asterisms appear in the night sky. And you can have the names with, you can have it with or without the names of constellations and asterisms. You can have them overlap. If you don't like the default colors, every time you go into one of these tabs and you see these squares right here, you can change the color. So you can contrast the coloring, whatever coloring you want. The hue, the saturation, red, green, and blue. Now, we're finding some object in the night sky. We naturally go to the search window. We type in the object in the text bar. So here I show the constellations. I bring up an object, and either if it's in the, if I do it in the find window, I just press the enter key, it'll center on the object. Or if I scroll across the sky and find the object, I click on that, I can press the space bar and center on the object. So this is the object. It gives me the reference data. The I key gives you the images. The D key just gives you the deep sky object. So you can do it with or without the images. Just ignore that, that's M18. And here's the information with the Trifid Nebula. So you get cross catalogs, you get the redshift, you get the distance, you get the size. You get fancy things like the parallactic angle, or you can get things in the supergalactic coordinates, or even the surface brightness, or even the Dreyer cataloging for the object. Now for planets, if you include the atmosphere, it even will give you the extinction coefficient for the brightness, depending on the air mass, as the object goes high up above the sky or low in the sky. So we do this for Venus. There's the data for Venus. So you get the subsolar point, the albedo, and of course you get the distance from the sun, the distance from the Earth, the light time, the orbital velocity, the synodic period, the apparent diameter compared to you see through the atmosphere. I ballooned up Venus. And if you're not familiar with the parallactic angle, right there, it's just the angle from the object compared to the observer's zenith to that of the north celestial pole. And you always use the page up key to enlarge the object, or the page down key to make the object look smaller, depending how much of the sky you want to observe. I'm going to open this up. And this is what you see if you want to do this in the night mode right here, which is the red eye feature right there. Of course, you adjust the brightness of your monitor. You put a red acrylic screen over that. You can actually cover the entire sky, your monitor with the sky itself, so it's completely in red. Now, program extensions. There's lots of program extensions. Particularly, you can come over to here in the sky itself. You can eliminate all the solar system features. You can add in spiky stars. Again, you can adjust the brightness of the zodiacal light. You can change the absolute scale and the relative scale and do different projections. Right now I'm at stereographic, but you can use anything from equal area to the hammer Atioff, to the sinusoidal, to orthographic, or even the fisheye perspective. And you can even change the vertical viewpoint, how offset you are in terms of percentage. And of course, everything can be proportional depending on your field of view. You can even go crazy on the labels and markers for stars. Now here in the sky itself, so if you're not careful, you can just about label every star. So just be moderate with the star labeling, unless you balloon up the sky itself for the catalog of those stars, because all the stars have cross cataloging. And this is your options for all the grids you can have. So again, if you don't like the color, you can change it. So this, of course, this is right here, we're around Draco. So this is going to be your I think that's the ecliptic grid system. And no, I'm sorry, that's the equatorial grid system, because there's Polaris right there. That, of course, is going to be for the azimuthal grid overhead. Right over there, that's going to be for your galactic coordinate system. And right over there is going to be right around Draco. So that's going to be for your ecliptic. So you can find your ecliptic North Pole, you can find your galactic North Pole, your supergalactic North Pole, your equatorial North Pole and South Pole accordingly. And right here, you can adjust everything in terms of what you want to appear on the celestial sphere. You got your colors, you got your precession circles, you can reflect the Earth's umbria and preumbria in the sky, the galactic poles, the anti-solar point. These three right here, these three central lines, this just projects the lines such as the equator and the galactic equator. If you want to see marker increments, you get the middle row right here. If you want to see positions in terms of numbers for angles, that's this column right here. And you click on any of the squares, you can change the coloring. So again, you get that color feature. Oh, by the way, you can adjust the field of view right there. So you can change your rectangular field of view and your circular field of view for your angles in degrees. Now, right here, that's going to be your galactic. Right now, this is the galactic and this is the supergalactic equator right there. And again, you can project the poles on the night sky itself. So here you have the markers. Here you have the angles in degrees. Here you can see the constellations. So for the North Galactic Pole, it's right here in Coma Berenice. Now here's Saturn, here's Sagittarius. The field of view is 8 degrees. So I press the D key to project the night sky, the deep sky objects, and the I key for the background images. Boom. I can go to the digitized sky survey, that's known as the TOAST. And here you get the image that's accepted with the regular RPG, but if you do it with the deep, this comes from the digitized sky survey, you get a different perspective. Now, the benefit of this is that you can find deep sky objects that don't have a background image in here. And it's not limited, it's just the Messier. You also get that with some of the other different types of objects in the different catalogs. And there's the HIP survey option. There's just different wire mesh surveys to project objects in the sky. Make sure you do it for a narrow area of the sky because you have to have patience for uploading the DSS because it's a lot of data. But I recommend reading the manual for more information. And that's the DSS sky, as you can see across the Milky Way. Now, extending your features. Well, you got the 7 tabs, you got the main information, the extra time tools, scripts, and plugins. We'll go through that. Any detailed information of any object will be in the information tab. You can install a maximum number of star catalogs, 177 million stars down to 18th magnitude. You've got compass mark icons. There are different time correction features. Then there's the tools, the scripts, and the plugin tabs. So the way you can arrange this is that you can have your small script right here and lay out your numbers here for your coordinates, or you can have it in the traditional manner, or you can have it to where you have the lettering here, the numbers laid out like this. So it gives you the options of how you want to lay out this data in your reference data to make it as clear as you want it to be. And the compass markers right there. That's right there. And this is your help window right there. So the configuration window is F2. The astronomical calculations is the F10. The help window is the F1. And these are all the keys. Now, as you disable and enable the plugins, it will change the listing of the different types of keys for the plugins. Not all the plugins will have keys that you can use on the keyboard to activate those features. Just be aware of that. Also, there's for extra landscapes, for scripts, for Google Groups. So if you want to add in extra landscapes, there's a link down there to add in extra landscapes and give you instructions if you want to not use the default landscape that's given to you, but any other landscapes that you want. You can use the Martian landscape from Earth and see what the night sky looks like from Earth using a Martian landscape. 3D sceneries. I haven't loaded up that startup. I didn't activate that plugin, but here's all the plugins. So what you do here is that you load it at startup. You've got the configuration, so you can change the way you want to use those plugins. And then you turn off the program. If you want to load up multiple plugins, that I recommend clicking on all these or clicking on many of these to load them at startup. So the next time you open up the program, it'll load up the startups. It will load up those extra plugins. It may take a bit longer time for the program to start up because you're activating all these plugins, but it gives you all the extra features that you want. So each plugin will not load up while the program is running. That's a safety feature to prevent the program from crashing. So you click on startup, click the configure button. The new feature will appear upon restarting the program, and it'll just have you have a longer nav screen. So just be aware if your monitor isn't large and wide, you may have to be selective about what you're having for your plugins that you want with your program. But you can disable and reload them anytime when starting and restarting the program. So this is your DSO. So you can have up to 24 different catalogs. You get the Higgson groups, you got the supernova remnants, you got the Abell catalogs of galaxy groups. You have the ARPs, you have the Paracahutics, you got the Vandenbergs. So you have upwards of 24 different catalogs. You can filter types of objects. You can adjust surface brightness. All you have to do is click on the labels and markers, click on the filter by top, and you can adjust everything. You can even configure the colors of the markers. And you can even limit the angular size of your objects. So you have a lot of options, what type of objects you want to appear on the night sky. So this is your sort of your adaptable, adjustable star atlas. So here are the objects in the sky. You can do the outline of your nebulous and dark sky areas, particularly the Horse Nebula here in Ophiuchus. Get to that close up. So it's just like you get with Uranometria. And if you adjust it by the brightness of an object or by size, you can see how the open star cluster feature gets larger or smaller depending on the size of the object. So here I have this galaxy in Scorpius. So it doesn't have a background image, but if I activate the DSS feature, and it will pop up, you get more stars in the background. Right there. So you know if you want to go towards an object in the sky, it doesn't appear on Stellarium in terms of what it looks like. You can click on the DSS feature and it'll show you what it looks like. It's sort of the same feature they use on the Sinbad website. Now, the star lore. You're not limited to Western constellations. You can do constellations from any of the cultures here listed from 6 continents in the Pacific Ocean. So, and of course, you can change the constellation lines in terms of the color, the asterism lines. You can make the lines thicker. You can make them smaller. You can change the font size and the brightness in terms of the constellation art. This is the constellation of the ancient Babylonian, the Seleucid culture. Chinese have a lot of constellations. Or you can do something simple as the Navajo and get simple constellations. The sky tab, of course, this is the sky tab right here. So I can imagine, well, I couldn't say here is that you can adjust the temperature, the atmospheric pressure, and the extinction coefficient right here. Adjusting the atmospheric conditions depending on your altitude. You can make the stars disappear. You can adjust the shooting star bar. You can go real crazy and have your CHR be nearly 1 million meteors. You can change your projections of sorry about that, of the night sky, or you can simulate the sky in terms of the Bortle scale. So this would be in Houston. That's, of course, a Bortle scale. I believe it's 9. Or out in the George, there's 5. Or out in the middle of the desert, there's your 1 right there. So you can adjust the light pollution from 9 to 1. So you can imagine what the sky of Houston's would be like with no light pollution. And of course, putting in the Milky Way itself, adjusting the brightness, so you can adjust the saturation, make it look black and white. So you can adjust the profile of the Milky Way. The Solar System Objects tab. You can actually change the scale of how the planet's going to look large and small from the moon, the minor bodies, the planets. You can make them look big, you can make them look small, but they all magnify at the same rate if you saw them through an eyepiece. You can also deal with changes with the Great Red Spot. I don't know if anybody's familiar with WinJupos. It's a great website for looking at the passage of the moons passing in front of Jupiter, when you see the position of the Great Red Spot, and you can see the movement of the planets and the orientation, the movement of the moons passing in front of the gas giants such as Neptune, Uranus, Saturn. I can do a whole presentation on the WinJupos program. Also, the Earth shadow enlargement after the Dejon scale for determining the appearance of the moon during a total lunar eclipse. And of course, the pathway for the orbits. Now, if I adjust the Great Red Spot position, I go to the recent measurements. That's a link with the WinJupos site. So you can see where it is with what's known as the longitude in system 2, which is for the mid-latitude lines. Because with the gas giants, you have 3 different systems of longitude. There's for the polar regions, there's for the everything in between, and then there's for the magnetic field of the planets. For the gas giants, because they're gassy bodies, of course, you can adjust everything right here. So here's Jupiter. I can show the orbits. So I have the orbits of the moons, Or I can change the magnification, make it 50 times larger. This is the same area of the sky, so I can make Jupiter appear very big, and I can eliminate the orbits for the moons itself. So you can adjust that scaling over here. Now for the advanced features, the plugins. So for the exoplanet, pulsars and quasars, the red right here, those of course are going to be your quasars. The green circles are going to be for the exoplanets. This is with a lot of the planetary surveys, particularly around Cygnus. And then of course, the blue crosshairs are going to be for the pulsars. The navigational stars are circled in red. And you actually have a feature where you can show the coordinates of your mouse pointer across the sky. And of course, you can show when objects are going to be visible this year or today for any object of the sky you point at. And here's the information you can get for your quasars, pulsars, and planetary systems. So you get all sorts of data. You can look at the barycentric period. You can look at the spin down energy loss rate. You can even get the redshift and look at the distance. And of course, you've got the angle measurement between the DSO. The navigational stars, you can see the red circles around them. Here's the asterism. I don't know if anybody knows this, but that's a little Cassiopeia right there. The mini Cassiopeia. And you can see how you measure. When you measure everything, you always start off from the first target, gives you the angle, so you can measure the distance of the dumbbell with respect to the position of star 51, which is Altair. And you can measure where you are, particularly along this asterism right here. So it's very good to get yourself trained on star hopping and galaxy hopping using the angle measurement device, which is right there. For the navigational stars, that's that feature right there. For using the marker to go across the sky for the coordinates, that's going to be this feature right here. And then this feature right here in the middle, which shows the star rising up, that gives you the observability right here in the blue, in the lower left-hand corner. The equation of time, you can adjust this for the solar analemma. So you can see where the sun is shifting across the sky itself. This varies by the changes in minutes to where the sun will appear at its solar noon, not to be confused with 12 o'clock, because this is January 1st at 1:30 in the afternoon. That's the summertime. So as you move over to here, you're going to have longer daylight time. Whereas if you go into autumn and spring, we expect the sun to be way over here towards the right, which means you're getting your solar noon well before 12 o'clock. And there you are at on December 1st. So you see where the position of the sun will be at that same time. So you can plot out that analemma. That's the result of the Earth being in an elliptical orbit around the sun. And then, of course, you've got the plugin for the compass itself. You can overlap that with your equatorial coordinate system. That's that feature right there. You can also overlap that with the galactic coordinate system and Polaris Galacticus Borealis. That's 30 Coma Berenices. That's your North Galactic Star. So you have a North Celestial Star where you have a North Galactic Star. And there it is right there. Up close. And you can see where you are with respect to the Northern Coma Cluster, which is the galaxy cluster right there. And there it is right there. So that's your North Galactic Pole. Now, meteor showers. You actually have one feature in which you can search out your meteor showers during a time range. You click on that, you can find your meteor shower in the night sky with the radiant. And then you get your information when you have the activity your maximum night, your CHR, and the parent body, and the population index, and the meteor velocity, the radiant drift, so forth. You can even, oops, what happened? Okay. Oops, and right there. So this here, this feature on the left with just the meteor showers, that's the toggles. You can make the radiance appear in the night sky. This over here with the magnifying glass gives you the meteor shower search. And you can do this in real time. So you can wait over an hour to see 25 meteors pass by across the sky, or you can go crazy and use the 1833 Leonids and get them popping all around the sky, and you get all your radiant zones right there. So you can simulate meteor showers on a cloudy day. And of course, you've got your satellites. You press the Control Z, you get your two-line element, which is your TLA data using Kepler's orbital elements. And you can plot orbital paths of satellites across the sky, just like the solar system bodies. And that's right there, that satellite feature. So you get your satellite, so you can get the coordinates and the velocities, and you get the latest update. You can get the range, you get the altitude of the satellite. You see how it moves across the sky. This is the Ocular feature. This is what I like. You got to activate the plugin to appear right there. Of course, this is the Telrad, the Ocular view, the telescope and imaging, the Ocular's windows to set everything up. And the Ocular windows, you can change your field of view depending on your. Sorry about that. I'm just recovering from a cold. So for the field of view, you can list the optical properties of your telescope, the sensors for astrophotography, and the eyepieces. You can get your Telrad. Oh, you can adjust the angles of your Telrad. So you can adjust the inner, the middle, and the outer ring. So you don't have to stick with the 1/2 degree, 2 degree, 4 degree. So you can make the Telrad look big, or you can look small. You can just restore it to its original features. There's your Telrad, right there. The great star cluster in Hercules. The second feature, of course, gives you the lidded reticle right there. You can adjust your eyepiece. Of course, you have to put in your eyepiece right here in the setups. So when we go from one eyepiece to another, we can increase the field of view, change the eyepiece size, get the magnification, get an enlarged view. You can even put in the lidded reticle, which is right here with that feature. There's actually a feature in which you can lit up the reticle, so you get north, east, south, and west. You can flip it upside down. You can do it inverted. Be aware that the celestial sphere option is disabled. You got to go back to the sky viewing options window to enable that again. So you can get the grid system. So if you're plotting comet's position of a comet across the sky, even though we don't have ANSYS-like instruments anymore, you can do a virtual version. You can do this virtual version of a bifilar micrometer. And naturally, you can upload. I think you can upload your images on Stellarium and see how your objects move across the sky and actually measure, including the length of a comet's tail. Now, I don't know much about the telescope control plugin, but I know that with the Fort Bend Astronomy Club, they have what's called Stellarium Scope WD. So if you want to use something like Sidereal Tech, you have the ASCOM driver with the encoders. It will communicate with the Stellarium scope, activate the Stellarium scope. It'll communicate with SciTech. Then, of course, you can control your telescope with Stellarium. But that program no longer exists because now all you need is just the ASCOM driver for the telescope mount, because Stellarium scope is now built into Stellarium 21.0, and this is where you set up in the window right there for configuring the telescope. And Control M allows you, instead of moving across the sky back and forth with Alt as, you can do it RA and deck like a real scope. Well, with a conventional scope with an equatorial drive. That's that icon right there. So let's simulate the events. I'm going to simulate for you the 2047 eclipse, July 7, this comes from the NASA eclipse site. So you just locate the eclipse. Here's the area of visibility. This goes right through nearly the umbria of the shadow, right towards the anti-solar point right there. Do this in Hawaii. You get the start time, the stop time. So right here is that date. Here's the moon. You get the percentages in terms of the change in the penumbral and umbral eclipse magnitude. And there's your moon right there. Very, very dark. Now there is something called, I don't know if anybody's familiar with the Dejon scale. It's the scaling for the brightness of a lunar eclipse. So this is the 2047 eclipse. That's the eclipse we had recently. That's the Dejon scale right there. So it depends whether the moon is at perigee or apogee, and whether it crosses across the breadth of the umbria, or only part of the umbria. And there it is right there. So basically, if you have a D0, you're going to have the maximum darkest eclipse, the D4. The moon is only going across one corner of the umbria, and it's going to be at apogee, its furthest distance. You can also simulate occultations. I go to a program called Occult4. It's a freeware program you can download. You go to the inthesky.org, and you can simulate the moon occulting Venus. Sorry about that. And you can actually see the sky with the Manila. So this is from Manila in the Philippines, right there. So you can see the eclipse. You can see the occultation before, during, and afterwards. So you can simulate occultations. You can also simulate conjunctions right here. So this is a conjunction at the George Observatory on the 13th of July with Venus and Mars. You can see it's at 9 p.m. and you can magnify everything. You can scale it by a factor of 30, even up to a factor, I think, 500. So you can see these planets magnified as if you're seeing them through an eyepiece. Oh, you also get the angle, and I forgot to show on the reticle, is that you can also get the position angle as well. And so Mars, with respect to Venus, is rotated 231 degrees east of due north. And you can do that, of course, with the lidded reticle, going back to the ocular feature. So Stellarium has a lot of cool features now. And this is one grand feature, the astronomical calculation window. So here, what you can do is you've got for the positions, for locating objects, deep sky objects down to 25th magnitude, solar system objects, ephemeris tab with 1 or 2 solar system objects. You can get the data with timestamps down to 1-minute increments. There's the transit tab with one object with respect to another. The phenomenon tab dealing with the position of objects with respect to their elongation from the sun and the moon and the elevation above the horizon. There's a graphics tab, particularly for plotting comets. And I don't know if you're familiar with What's Up Doc with Aaron Clevenson with his Excel file, where they got What's Up Tonight with the What tab, and then there's the Planetary Calculator. So I go here to positions, I find Venus, I select the sun with Venus itself right here, and I can see that data right there with the lines, the dates, and the markers. Here I did it with Saturn and Venus, so you can see both bodies undergoing retrograde motion. Here is with Venus, and here is with Saturn, and you can change the time range, and you can do the time step down to 1 minute. But if you do it, just be aware it's going to take a lot of time because it's a lot of data. So you want to avoid putting down the dates and magnitudes. Otherwise, it's just a lot of information overlapping unless you're plotting it over much longer time increments. So I did this with the Venus transit for 2117. So you locate the object, you open up the astronomical calculations window, you do all your settings, you get the reference data point for the transit, you get the right date and time range, you get the date for the minimum solar elongation, where you can click on here for the minimum solar elongation. Then, of course, you go to the ephemeris tab itself, and basically you get your data. Then you go to the transit tab. Then you get the phenomenon tab. And then it gives you everything that you can plot out here on the screen. If you want to clarify if if certain features are not appearing, I always recommend to clean up the data in the ephemeris, in the transit, in the phenomenon, and then of course you can reload everything. Just be aware with a small time increment, depending on your range of date and time, it could take a long time for your computer to process all the data. And I always refresh everything with the cleanup and do the cleanup for the 3 tabs, which is the ephemeris, the transit, and the phenomenon. And if everything, you can just clean up everything, click off the feature and reopen it. Now, features and capabilities. So I did this with Comet 10P Temple. So you get the comet, you get the path around there, you can see the orientation of the tail. So you can always refresh and include new minor planet data. So you go through the configuration windows through the plugins, you download the comet data, you can update existing objects, you can mark everything, you can add objects in terms of new comets, new asteroids. Then you close all those windows, you go to the Astronomical Calculations window, and boom, you can get your graph right here. So it shows the angular size of the comet and its change in magnitude. You can do it over 1, 2, 3, 4, 5 years. And here's all the data you can get. So you can look at the angular size of the comet, the distance, the elongation, the magnitude, the transit altitude, and everything's done in reverse to time. And you get altitude versus time, azimuth versus time, lunar distance. You don't have to look at the comet when it's on the night of the full moon. It doesn't give the position angle of the tail or the tail foreshortening, how the tail looks with respect to Earth, but you can get that from the phase angle. The phase 0 to 1 deals with the phase of the moon. The transit altitude as it goes across the meridian, but you can use astrograph or sky tools to get that extra data, or use the Minor Planets Comet Ephemeris Service website if you don't want to pay. If you don't want to pay for these programs here, astrograph is very good at using that. Sky tools primarily for tail foreshortening, but it doesn't do it for all the comets. And then here it's the what's up tonight. So plug into any set of objects, get your angular size, any time of the night, and you can figure out what's up tonight. And you can adjust the magnitude to 21st. You can get your list of planetary nebulas, open star clusters, or you can do the planetary calculations table. So you can see the position of Saturn with respect to, well, the position of Titan with respect to Saturn. So here, of course, we can see the linear distance of Titan from Saturn. Also, you can get the angular distance. So you get the best time to look at Titan when it's far enough away from Saturn. And you do that with any combination of bodies in the solar system. You get the data and then you get the graphs. So it's evolved a lot since 2000. New features are being added all the time. You can always recommend to Stellarium through their blog the features you want to add on. You can go to the Simbad site to add in some DSO objects you would like to observe. It has many limitations, but it can do a lot of simulations such as eclipses, transits, occultations, conjunctions, star patterns, movements of artificial satellites. It's a great program to operate telescopes if you want to use a freeware program, and you can simulate what you can see through eyepieces and Barlow's, and you can execute any citizen science or any education projects with Stellarium. And I don't know if you were following the 42 down here in the lower left-hand corner, but I found 42 and it's everywhere. So you've got, you basically got Jackie Robinson. Here's maladenium, the energy efficiency for a black hole. I don't know if anybody's familiar with the 3 x 3 x 3 magic cube. Add any number along the horizontal, vertical, or the diagonal, it adds up to 42. So that's my presentation. If we have a few minutes while I'm answering questions, I perhaps can show you the Stellarium program. So let's see if I can share that. So does everyone see the Stellarium program?
Certainly
Yes.
do.
Okay, so there's the Stellarium program itself. So right here, I can just, take away the atmosphere. Right here is something like the search window. So I go to the Simbad, I can click on an object, query around that, and get descriptions of the object. There's the position. I can use any coordinate system. Here's the listing for objects. So there's the diamond's cross. Of course, I can't really see the diamond's cross, but I can press the ground and get rid of it. And of course, I go to Alt A, and there's the diamond's cross right there. I can go to Alt V and show the name of the diamond cross. There's my constellations. Let's see, what else can I show you here? Of course, the landscapes. Let me go back to the ground here. Let me press the G to bring back the ground. There's the A for the atmosphere. So I can eliminate the atmosphere. You can see that for yourself. Of course, I can also eliminate the fog feature by pressing F. Let me just take away the constellations here. I mean the asterisms. Now, go to the sky and viewing option windows. There's the landscape. So let's say we want to try Mars. Ooh, and there's the surface of Mars right there. Can't really see it because it's nighttime. So you can change the horizon all around you. Like that. So you can change your horizon. Another thing you can do is change your location in space. So let's say I go to location window, and let's say I want to go to, let's go to Saturn. See if I can find Saturn. This is all in alphabetical order. There's the Saturn itself. So boom, there's the Saturn. Oh, there's the shadow itself. Of course, I can eliminate the ground. So there's Saturn all around me. There are your moons. There's Enceladus, there's Mimas. Go to Enceladus right there. And boom, I can even pick on certain features on Enceladus. I can do that with Moon. I can do that with Mars. I can pick a geographical feature and study it. So that's the extent of the program. Does anybody have any questions about Stellarium?
Yeah, Justin had a few comments. We'll go through them in order. David Brown, I think, had a comment, not a question, but said this looks better than Celestron's Starry Night. And yeah, in many ways, it certainly does. Bill Spitzeri had a question about the supergalactic equator. Bill, do you want to ask that question?
Yeah, the question is, what the heck is it?
The collective.
I've never heard the term before.
The supergalactic equator?
Correct.
It was a means used by de Vauquelin and other astronomers back in the early half of the 20th century to map out all the galaxies and clusters of galaxies. I can actually show you right here in the sky in viewing, right here with the markings. So here's the galactic and supergalactic equator. So let's see. Oh, of course, we have to go back to Earth. And the only way to do that is to go to the search, go back to the sky and viewing options window. Actually, let me go back here to the location window and return back to Earth. Okay, so we're back on Earth. And let's see if we have the equators here. Because it's a coordinate system, it helps when you have that right there. So those are your equators right there. In fact, if I put in the deep sky objects along the galactic equator, you can see how you line up all your galaxies along here. So if I were to take away the ground, go below here, let's see if I find Virgo, for instance. Let's see if I can find Virgo here. So let me
I
find.
understand what the galactic equator is. It shows you the plane of the galaxy.
That's right. And you have the supergalactic equator showed right up here. So
How is it determined? What is it really showing us?
it shows you basically along the galactic equator is the old survey of clusters and superclusters of galaxies that are lined up here like Coma Berenice. You come along here, you find all your galaxies along here. Where those galaxies were once mapped out, they could actually trace a line across those galaxies and treat that as an equator to look at objects beyond the Milky Way galaxy.
Oh, objects other than the Milky Way.
That's right. And they're
Gotcha.
at right angles to each other, believe it or not.
I understand that. Great, thank you.
Like for Virgo, you can find the groupings like the Abell clusters are heavily concentrated along the supergalactic equator.
Yep. All right. Chris Morris said, if not covered, you can input the specs of your telescope and eyepiece or camera and create a frame to indicate how much of the DSO will appear in your view. And I think you touched on that a bit, Justin.
Yeah, I did. That's going to be in the ocular feature right here. You've got your sensor, you have the telescopes, your lenses, you can add in lenses, add in eyepieces. So.
Yep. And David Brown mentioned he'd be interested in knowing how to use telescope control. I know you touched on it a bit. Is there anything else that we can show in the program itself here? Or I think you did a pretty exhaustive search of it. We don't have a telescope to control necessarily here.
No. But the telescope control itself, I don't know that that feature very well, but sorry, but that's going to be. Where did I see it? Actually, it's down here. For the telescope itself. So this is the SLU telescope. Here's the configuring of the telescope itself. So you have your options. And of course, you have to be able to communicate with the Stellarium by having the ASCOM driver with the ASCOM driver with your telescope mount. And then it should be able to communicate with the telescope directly. The manual will have all of that information available.
Absolutely. Chris Morissette, did you want to ask your question about the North Galactic Star?
Yeah, well, I think I kind of touched on it with Bill's question, but just to make sure I'm clear, the galactic coordinates basically are saying that the equator is the dust lanes or the
Yes, it's the plane of the Milky Way galaxy.
Yeah, okay. Yeah, that's all I was in. Now what would you use that for? Is there any practical use of that coordinate system?
Well, there's a limit to using the RA and DEC, the equatorial coordinate system, particularly if you're trying to use radio astronomy to plot objects that you can find on the other side of the Milky Way galaxy. So this is a means of plotting objects around the Milky Way using the Earth lined up through Sagittarius to the center of the Milky Way as a frame of reference.
Okay.
What professional astronomers use.
Gotcha. Thank you.
All right. And our good friend Dan Roy had a comment. Dan, I'm not going to read it. If you want to come off and mention this itself, because I think this is a fantastic idea and you've done this to great effect over many years, and just want to share kind of some of your stories with Stellarium. I think Dan's still on mute there. But for those who don't know Dan Roy, Dan is a member of HAS for several years, does a lot of fantastic outreach events. And unlike many of us who cancel when it's cloudy or rainy outside, he actually brings a laptop out and shows people things in the night sky using Stellarium. So, wonderful way of doing outreach as well. And then Bill, you had a question about what the cost of the program was?
Someone answered it. I thought he said early. I thought he said early that it was free, and I thought maybe my hearing aids weren't working, and that could be because the number of features are staggering.
It really is.
It's a freeware program.
Yeah.
This is the anti-solar point. Here's the layout of the shadowing. So this would be the umbral and the prenumbral shadow of the Earth. And then over here is the precession circle right there.
Okay, sorry guys, I was out for lunch here. Yeah, sure. I never cancel a star party. I think that if people have come, even if it's raining cats and dogs, of course, I'm very fortunate to have the support of Lake City. And we have a nice shelter. And inside the shelter, I have power. So I can show all sorts of stuff, which is what I do. I would strongly recommend that whenever anyone does a star party, and I know all of you do, okay, you don't necessarily go to the top of the roof and scream it to the top of your lungs, but I know you do it. So whenever you do that, I would strongly suggest that you consider showing this fantastic software, not to the level that Justin went into, because that's a lot, but just show them how to do the constellations. Just show Saturn. Saturn is just a pleasure with Stellarium. So anyway,
Press C.
Use that instead of canceling.
Press C for constellations. Press V to show the constellation names. If you want to find Saturn, you just do the search window, object, type in Saturn, and boom,
Okay,
right there.
and then zoom on it. Just zoom, remove the Earth, and then zoom on it. Control, yeah, that's it. Look at that. I mean, you cannot show that with your telescope. So
You
it
can
is
all-
highly recommended.
Yeah, and for those who don't know Dan, he certainly knows what he's talking about here. He and his wife Rebecca won the was it 2018 Dan Omega Centauri Award from the
You
Texas
should
Star
know
Party.
because I owe this award to you. Yes,
I know.
correct.
So yeah, Dan Roy won that very prestigious award, and a lot of what he's done has been with Stellarium. So
Yeah, that's Dan
absolutely.
and Rebecca. Okay, Rebecca and me.
Yes. Okay.
So
I'll
here's
put
the
her first then.
saturation. I'm making the Milky Way look brighter and brighter. And here, that's the brightness. And I take out the saturation and look, black and white. So.
There you go. All right. Any other questions?
Hey, Joe, just one comment.
Sure.
This is Chris, I have been able to get Stellarium to operate my mount. I mean, it was a real science project, but I got it to work. If I know there was a reference that Justin presented to go look at, but if anybody wants to pursue it further, I'd be happy to share with anybody my experience so they don't have to reinvent the wheel.
Oh,
I know that the Stellarium scope software no longer is supported, and that the features of Stellarium scope are in Stellarium itself. So allegedly, if you have the ASCOM driver for your mount, you should be able to communicate with the Stellarium program, and that way you can control your telescope.
Correct.
Yeah.
Yes.
Yeah. Chris, no, I appreciate the offer there. Is there a preferred way for people to get a hold of you?
They can just they can email me. I can.
Okay.
I'll just send it out. And if anybody wants to, they can get with me one-on-one.
Okay, perfect. And if you want to throw that in the chat too.
Yeah.
people can grab it from
There
there.
you go. I forgot about that.
Yeah, there you go. All right. Any other questions or comments for Justin before we wrap up for the evening? All right. Well, hey, Justin.
I'm sorry.
Go ahead,
Here's
Bill.
a comment. Justin, fantastic job of covering a very rich topic with lots of details. You did a great job. Thank you very much.
You're welcome.
Second.
Wonderful. Thank
Yeah,
you,
that was
Justin.
really-
Yeah.
It's really good.
Absolutely. And it's funny because I use this program not as much as I probably should, but every time I'm in it, I learn a little bit more about it. So,
And
Chris,
beware, it's
yes.
free.
yes, that's true. But it is a very feature-rich program for being a free program itself. So the development community has done a wonderful job with it. So, and Chris,
Hundreds of people. Hundreds of
absolutely.
people.
And Chris, I see your email in the chat. So folks, go ahead and grab that now if you want to chat with Chris about how he set the system up for telescope control. And again, Justin, thank you very much for a wonderful presentation tonight. And really looking forward to more people using this program and supplementing their observing with the Stellarium product itself. So thank you.